So, another IP experience, this time with Scott Hanson, who's the CTO from Ambiq. We originally talked about Ambiq in relation to Rack Wireless's Rack 11720 module. It's kind of the heart of that, Bluetooth and low RSOC. But hearing the Ambiq story from the source, this is a very incredible technology, and so much thought has gone into producing the lowest power processor, and I quote, on the planet. Enjoy.
Today, we are joined in the world famous studios of ipXchange by Scott, who is the CTO of Ambiq, who's going to tell us all about what they do in low power and talk about specifically, I think, this board. But I'm going to leave him to start the introductions, and we'll see where he leads us. And then
Perfect.
We'll go. Hello,
Perfect.
Scott.
Hey, and I appreciate you having me here today. Very happy to be here. So I'm here nominally today to promote the Apollo 4 display kit that you just showed there. And we'll talk about that. I want to talk about that. Apollo 4 is our latest flagship SoC family. We've got a wide range of features there. And I want to talk about some of the really cool things our customers are doing with graphics, with displays, all on tiny batteries. But I think for your audience, it makes sense maybe to start with a quick overview of Ambiq as a company. So I founded Ambiq 13 years ago. Today I'm CTO of the company. That means I drive technology forward. I make sure that we continue to offer the lowest power chips on the planet. And when I founded the company 13 years ago, the vision was to put chips everywhere. When you put chips everywhere, more likely than not, they're running on a battery, right? So you've got to be hyper efficient. If the 1990s and the early 2000s were about gigahertz and the gigahertz wars, today we're very much about picojoules and microwatts, right? So it's a very different view on things. We talk internally about being picojoule fanatics, right? About caring about every last picojoule. And we've got a really cool technology platform that I'll walk you through later that allows us to deliver unmatched power. But I guess back to the founding of the company. When I founded the company, Internet of Things was just emerging as a term outside of the academic world, right? So we would go in and talk to investors and say Internet of Things, and they would go, "Wait, I don't really know what that is. Explain that to me." Of course, today that's not the case, right? People like you have made sure that the world knows what IoT means. But we were doing research at University of Michigan. That's where I did my PhD in what is now called IoT. And specifically, there were a lot of topics like smart dust that were really cool, right? The concept of let's shrink an entire wireless sensor system down to a dust mote, and it can go everywhere. At Michigan, we were really focused on this concept of a cubic millimeter computer. So if you can shrink down the battery, a solar cell, sensor, radio, antenna, microprocessor, all into a cubic millimeter, you can do amazing things like put it in somebody's eye, right? So we were actually building sensors that you could use to track glaucoma fluctuations or pressure fluctuations in glaucoma patients, which was amazing. Now, the reality of building such a system was pretty far out, but I got to the point where I said, actually, this is commercializable. This is something that's actually ready for the prime time. So I founded Ambiq, and the idea was let's take the microprocessor SoC piece of things and take it everywhere. It's not just medical implants that could benefit from this. So I founded the company, and we wanted to help make this nascent Internet of Things thing happen. And we built a series of products. We started really small. If you go to our website, you can see that we have a family called R2C, which is a real-time clock chip family, which is kind of a crazy thing for an SoC company to be selling, but it was a great way to start, right? It was a way to showcase our core technology, which I'll discuss here in a second. But then we built a family of SoCs called Apollo, and we've gone from Apollo 2, Apollo 3, all the way to Apollo 4 now. And I'll say, without pre-announcing certain products, we have some follow-on generations coming very soon that we could talk about another time. But what makes all of this notable is that Apollo is the lowest power processor on the planet. We have a technology platform that we call SPOT. So you told me before that you're not a circuits guy, you're not a technology guy, but I'm gonna give you a quick.
Oh, I'm stupid.
I'm going to give you a quick Circuits 101 lesson here, okay?
No comments, please, in the LinkedIn comments about that. Thank you. We all know that. No need to endorse it. Carry on.
So, well, here's your Digital Circuits 101 class right now. When you take indeed a Circuits 101 class, what they tell you is a transistor, the building block of the entire chip, is either on or it's off. So we turn it on by applying a voltage that exceeds its threshold voltage, its turn on voltage, right? And so you turn it on, you turn it off. You can see how that translates to zeros and ones, right? If you have a digital switching element that's on and off, zeros and ones. That's a pretty simplistic view that is powering every single processor that you use in your phone and your computer or whatever. It turns out, though, that's like if there's a more nuanced view that's possible. It turns out that you don't have to turn the transistor all the way on for it to work like a transistor. And that's what we take advantage of at Ambiq. In particular, what we do is instead of applying a really high voltage to turn that transistor on, we apply a very low voltage that just kind of barely turns it on, okay, or almost doesn't even quite turn it on. We operate in the so-called subthreshold or near threshold region, and another way to think about it is we're using the leakage of the transistor to compute. So instead of kind of turning the transistor on, having a ton of current and getting really strong ones and weak zeros, we're using the naturally occurring leakage in the transistor to compute. And what matters is not all that. What matters is energy is voltage squared. So as I drop voltage, the supply voltage to the chip, I'm getting a quadratic energy savings. I'm getting a huge energy savings, okay? And maybe another way to think about it is instead of representing a 0 with 0 volts and a 1 with something like 1 or 1.2 volts, if you drop that voltage that represents a 1 to maybe 0.3 or 0.4 or 0.5 volts, you get a huge energy reduction. That's what we're doing. So this concept actually isn't new. We didn't invent it. It's been around since the 70s, certainly. Actually, if you go back and look at the watch industry, a lot of the Swiss watch innovators were developing subthreshold circuits a long time ago. But it's been avoided. It's not been something that's used in a widespread way. It's very difficult. You get amazing sensitivities to temperature fluctuations and voltage fluctuations and manufacturing variations. It's so impractically hard that companies avoided it. And that's where we came along. We developed what we call our SPOT platform, subthreshold power optimized technology, which is really just marketing speak for the whole set of techniques that we use to address those problems, right?
So can I just bring you back a little bit?
Yeah.
You described just right at the start of your talk, you talked about SoC with a whole bunch of sensors around it, and then power, and then also all sorts of other stuff. And then you described, oh, well, hang on a minute, we can commercialize that. So you've focused on the SoC bit of it. So which bits in and I recognize the whole low power pitch. So we'll come on to that a little bit later. We'll come talk about low power and where you apply it. What's your definition of an SoC in terms of what it's got on it and what you offer? So because without being too cliched, one man's SoC, is. So what's your definition of an SoC?
Yeah, that's a fair question. So in my case, if we look at the Apollo family, there is an MCU core. So in our case, a Cortex-M class core. We have Cortex-M4 in our current products, but you'll expect to see other processor cores in upcoming products. Generally, there's some non-volatile memory for code storage, for neural network storage, whatever. Some SRAM. In our case now, we have other accelerator cores. So we have a GPU in our latest core. So this is it's got a GPU and a display controller, so you can drive big displays. We have generally a nice set of analog peripherals that might include ADCs and audio interfaces, comparators, this sort of thing. We have radios, so Bluetooth in particular is something that you'll see in our existing portfolio, Bluetooth Low Energy, and then a whole host of other peripherals that one might expect. SDIO interfaces, I2C interfaces, SPI interfaces. So whether you want
That's
to
a
call it an
lot.
SoC, yes.
That's a lot. And then are you tied to those peripherals? So if you go with your if you go with your core,
Mhm.
is everything based on the peripherals all being based on that core, or can you pick and choose?
Um, let's put it this way. We have a broad family of products, so you can kind of select a product with fewer peripherals, with more peripherals. The great thing is many of our customers say, your chip is lacking a function that we need. They can hook up an external chip. We have every interface imaginable to talk
Okay,
with those chips, right?
right.
So, for example, I strongly prefer to do analog to digital conversion on chip because we're really good at that. But
Yeah,
there's some sensor partners who say, "Hey, listen, we like to do the analog to
yeah,
digital conversion on our chip. We're happy to let them do that."
right.
So I think between supporting off-chip, interfaces to interface with these other chips and offering a full spectrum of products, I think we've got that covered.
Right. So the real answer to that is, you know, everything that you probably need is on there. But
Mhm.
if you take the interaction of a sensor with a system, sensors is, it's obviously not infinite, but the number of sensors out there is absolutely vast. So there's going to be
Mhm.
choices that people have to make. So you have you have the ability to offer the interaction without too much complication. Is that the answer to the
Yeah,
question?
yeah, that's right. That's right. Yeah,
Okay.
and in fact, if you look at the company, if you look at Ambiq, we employ a lot of software developers at the company. I mean, I think this is pretty standard in 2023. If you're a chip company, you employ a huge number of software developers, right?
Yeah.
In fact, most of our field engineers that support customers are themselves software developers. And so a lot of their time is spent doing exactly the work that you just described, which is interfacing with other sensors.
Yeah. Yeah.
We spend a lot of time understanding we have very strong dedicated support for our big customers, and what we do there is we learn what peripherals they care about, we develop the right drivers, and then we make those available as part of our software development kit that we provide to all customers. So we support a broad range of third-party sensors and third-party accelerators and third-party radios, and so as your community is discovering other sensors maybe that they want supported, let us know, right? We love to support new
Yeah.
sensors all the time.
Yeah. Very good. So you have an official partnership program where you know for a fact that these peripherals will absolutely work with your SoC and will absolutely interact, and you have lock and load ready software so that if you go with that partner as opposed to what is already on the board, everything will be fine.
Yeah, that's right. That's right. And that actually brings us nicely into the Apollo 4 display kit that we're here to talk about. Exactly an example of something like this. So in that case, it's a board that you flashed up earlier that has display, a little 454 by 454 pixel display, something that looks like a smartwatch display. So this is something a lot of
Yeah.
our customers are developing on today.
Yeah.
But when you dig into the Shield board, there is a PSRAM chip that you can use, basically a really low power DRAM chip that can be used to store frame buffers and graphics assets, etc. There's also a eMMC controller, so there's a NAND flash, giant NAND flash chip there. There's a NOR flash chip. There's an accelerometer. All kinds of cool stuff. I mean, you can pretty much develop a smartwatch or a smart medical device all on that little display shield there. And what comes with it is not just the hardware; it's all the software that makes sure that all those peripherals can work out of the box.
Right. Right. Okay.
Yeah, we've got customers developing neural networks on Apollo today, and so this shield, this Apollo display kit, Apollo 4 display kit, is a perfect platform for that kind of thing. So, imagine that you're a medical wearable developer. You want to have gesture controls, or you want to be able to identify an arrhythmia in the heart rate. This is a great platform for doing that. We also provide a lot of software that gets paired with that, both the standard software development kit, as well as something we call Neural Spot, which I can come back and talk about another day. But it's a whole suite of software that's meant to accelerate neural network development on a platform like this. So we hope that people will use this as a quick way to prototype cool product ideas. If you want to build a wearable, you want to build neural networks, you want to build a thermostat, I don't care what you want to build. This is a great platform for that.
Right. So now, when you use the phrase, so I'm going to just bring us back to basics, because we've obviously, where we started was, well, we actually started with what was the definition of your SoC. So you articulated that very well, and you explained what your definition of an SoC was. What's your definition of low power?
Okay, that's a good question. It depends on the use case, but I would say that low power is when you're trying to fit your entire power budget in a milliwatt or less. You got an average power budget of a milliwatt, but you want to do a lot in that milliwatt, right? You don't just want to sit there and occasionally wake up and measure a sensor. What you want to do is run tens of megahertz of processing constantly. You want to be analyzing sensor data. You want to be communicating over a radio. You want to be lighting up a display. And you want to be doing all of that on the order of 1 milliwatt. Sometimes that's 100 microwatts or 10 microwatts. Sometimes it's 10 milliwatts, right? It's one milliwatt plus or minus. And what you need to make that happen is you need to be able to do everything. We talk about our products as SoCs because it's not just about computing, or it's not just about analog to digital conversion or the radio. You have to do it all efficiently. And that's something that Ambiq and Apollo really specialize in is that full signal chain from collecting sensor data to pre-processing it to running computations on it to driving that display. You've got to do that with efficiency. If you had told me 10 years ago, when I was in the early years of the company, that we were going to have a GPU that could run at high speed, that we were going to have a processor that can run up to 200 megahertz, I'd say no, there's no way you could fit all that into a tiny power budget like we're talking about here. But between Moore's law and between the innovations that we've made at Ambiq, that's all possible now. So it's really incredible what you could pack into that tiny power budget these days.
Right. So when you talk about low power, obviously low power can actually be a device that spends most of its time off. You're talking about devices that actually spend most of their time being on.
Yeah, I would say it's both. And what I want to challenge my customers is they often come in with the mindset that my device must be always off because of its low power and because it's got a battery. Yeah. The thing I'm challenging them on is I say, hey, listen, we're making it so you don't have to make that compromise. We're going to give you such a low power microprocessor that you can run it in the background. So while others are forced to leave the chip off, you can process. In fact, that's probably there's one of three value propositions. When I go to a customer, there's one of three things that we deliver to them that they care about. One is some customers want longer battery life. Cool. Lower power means longer battery life.
That's where we would all assume that's
what we assume, right?
Yep.
But I'll tell you right now that is not the most common thing that customers want to use this for. The second thing is maybe they want to go to a smaller battery. Imagine a wearable. You've got a slim wearable. You want the battery to be as small as possible. You don't want to compromise battery life. That's where we help. The third thing, though, is the most powerful value proposition, and that is when we enable our customers to add new functionality. I'm going to give you the same battery life. I'm going to give you the same battery size, but you can do 10 times more work in that same footprint as before. So instead of maybe sitting there idle most of the time, you can actually be active. That's really compelling. Imagine that you're a consumer electronics company today, and there's this pressure every year. I've got to offer something better. I've got to give my customers an incentive to buy something.
It's all about
So if I can give them a new feature, whether that's you can now run XYZ neural network or add some wonderful new sensor and algorithm, that's exciting. So that's what we enable our customers to do, and I love finding new use cases. So I think your community of developers is the ones that are kind of pathfinding and finding these new use cases. So that's exciting.
Yeah. So when you talk about low power, just so that we're clear, please correct me if I'm just so that I summarize. We are really looking at wearable devices, be that predominantly medical and consumer devices, but you also mentioned some sort of industrial type applications as well.
Well, I would say that many of our customers today are in wearables. So if you were to open up name your favorite consumer wearable, I think there's a chance, more likely than not, that we're inside, that Apollo is inside doing some function. Sometimes the main processor, sometimes the co-processor. But we're in medical devices, as you mentioned. So think like wireless patient monitoring, which
Yep.
is more or less a wearable and maybe a different form factor. Maybe it's a patch, maybe it's
Yep.
a wristband, maybe it's
Yep.
a hospital gown, whatever. But we're also in smart home devices. So think smart doorbells, right? There's a lot of these ones that are battery powered.
Yep.
You need a little processor there to wake things up. One of the more impressive technological developments we've seen is smart credit cards. We have a number of customers in the smart credit card space who
Right.
are embedding a battery that maybe they've got a little display. These are some of the coolest devices I've seen, and there you got a paper thin battery. I mean, this thing has almost no capacity. So yeah, we're in a wide variety of markets today. Definitely the highest volume runners are in the consumer wearable space. That's just the nature of consumer electronics, right?
Indeed. Okay. So to summarize, we've talked about a system that you've packed loads of peripherals around on the SoC. You've got a big partnership program that will enable you then to seamlessly interact with a whole host of sensors if that's the direction you go in. You have a big bank of software support engineers that will help you integrate if you go a different route.
Mm-hmm.
And then I think the thing that you said that is really, really interesting is that it's a well, because of the obviously the clever thing that you're doing in software, you're going to be able to integrate the same battery with the same battery lifetime, but do more in software, so therefore add more features quickly.
Exactly. Yep.
If we were to
Exactly.
summarize it,
Yep, that's a good summary. Yeah.
Okay. All right. Now I'm afraid with ipXchange, this is always going to be a question that everybody that is on this podcast has to be asked. Your one solution. We're all about disruptive technology. You're clearly disrupting some very big competitors with
Mm-hmm.
being the lowest power solution. You
Mm-hmm.
believe to be the lowest power solution, and you've articulated a fantastic suite of solutions. You've articulated, and it's interesting. It's been done in a very intuitive way. I'd say the way you've developed your technology is very intuitive. Every time you've come across a problem, you've gone, oh, that's a problem to solve, and then you've gone away and solved it.
Mm-hmm.
So the big question for us, of course, is if you didn't exist, or if somebody is already doing these kind of designs, let's come away from consumer for a minute, because everybody knows the consumer manufacturers, but certainly in things like some of those medical and industrial applications, there must be some very obvious choices that you come up against every day. So who even though you have to admit it, if people who are considering, you've just given a fantastic background as to why they should choose Ambiq, but they're obviously going to be alternatives. Who would they be today?
Yeah. Well, I would say if you're using some of the really great broad solutions from, say, ST Microelectronics or NXP or Nordic or Silicon Labs, we represent a great option. These are all great companies, actually.
Yeah, they are, absolutely. And we don't, under any circumstances, say any different.
Yeah.
We're not in the business of that.
Yeah, and I would say that those companies offer an amazing breadth of product that is tough for us to match as a small company, but what we do offer is a really narrow focus on low power. So
Yes.
if you want the lowest power hardware and software, this is the company to come work with. Ambiq is. And oftentimes what we find is we're in sockets next to those other competitors, right? You've got they serve one function in the system. We serve the always on function in the system, right?
Yes.
And so
Yes.
we work with these companies a lot and think they're great companies. But I would say if you're using one of those companies today and are frustrated with power levels, come talk to us. We'd love to chat.
Yeah. So there's been what I take from our conversation is did you say 14 years that you since you
13 years, yeah.
So in a sort of healthy obsession with, you talked about a system on a speck of dust, a healthy obsession of how do we get there and what does that mean? Just because I'm interested, what's the you said, if somebody had asked me 5 years ago, could we have achieved the things that we've got on here?
Mm-hmm.
You'd have gone, no. I think you actually said, no, don't be stupid. I've never heard of do that. I think those are your words.
Yeah.
So in the next 5 years, what are those just because we're chatting amongst friends,
Mm-hmm.
what are the things that you would go, nah, don't be stupid, that won't be possible?
Yeah, well, I have to be. I'm an optimist, so the truth is that I've got some pretty ambitious plans of where we want to go. There's two pieces of it. Okay, one is I like to go up and to the right, which means we're always adding more features. We want to have multiple processor cores. We want to have a lot more memory. We want to have more radio options. We want to have more sensor interfaces. I would say, the one thing that maybe feels a little bit out of reach is, say, cellular connectivity on board. That's one thing. You look at the companies like Qualcomm, and they dominate that space. They do it extremely well. It's hard for a company like us to match that. And you've seen even other big companies attempt that. That one is probably out of reach. So hopefully I'm coming back 5 years from now and I say, hey, remember when I said cellular was out of reach?
I've got this board. I've got this board. Look at this board.
Right. But everything else, beneath that, whether it's Wi-Fi, whether it's multi-core, whether it's massive neural network accelerators or audio peripherals, these are all things that we're going to bring on board, some sooner than later, some very soon, in fact. So I'm optimistic, and I think it's for two reasons. One is Moore's Law is alive and well. When everybody talks about Moore's Law, it's the Qualcomms of the world and Intels who are saying, "Ooh, we're down to like a 1 atom layer thickness in our transistors, and we can't go any smaller," right? Well, in the embedded world, where IoT lives, we still have tons of headroom, right? I mean, the bulk of IoT revenue today is probably at 40 nanometers and above. Apollo 4 is a 22 nanometer product. You can bet that we have things in development that are below that. And the state of the art today is at 4 and 3 nanometers. So there's a big gap between where we are and where the leading edge is. So Moore's Law is alive and well for a while for us. That's great. That's good for our customers. It's good for your community. That's one thing. And the other thing is we're developing new technologies, right? My team in particular, as CTO, my team is looking forward and figuring out how do we enable these crazy things that our customers want. So, the other reason, aside from low power, that I think our customers come to us and that your community should consider us is, we're interested in pushing boundaries. We're really collaborative vendor. We work closely with our customers. We try to understand what crazy ideas they have, and whereas other companies might say, "Here's my portfolio. Don't stray outside that." I want to hear your crazy ideas. Let's talk about what interesting peripherals you want to add, and then I'll go back with my team. We'll figure out how to make it. So again, I'm an optimist. That's my job. It's to look forward. As CTO, I got to look forward and up and to the right.
So just on peripherals, just very interestingly, let's just finish the conversation on peripherals, because at the end of the day, if you look at the wearable market, if you look at the consumer market, if you look at the medical market, look at those things that you talked about, the whole concept of the doorbell being an IoT device connecting to your phone and giving you access to who's at your doorbell, that's a peripheral. So where do you see the trends today? Short term, just short term, because you've just given a more longer term version of answering that question. For our community, what can they, if they're thinking, I wonder if this is possible. Yeah, you've given a very long term. This might be possible, right? That's not today, but. Today, if in the next 6 months our community is saying, I wish I could do this, because it's all about incremental design, remember, that's where we started. It's like, how do I make my product 1% better than the competition? How do I make my product? So today, if you were to say, where are the trends in peripherals? Where are the absolute sweet spots that you see around your chip?
Yeah. So I would say the biggest thing, and this includes my chip, it includes my competitor's chip. One of the best tools that anybody has in their toolbox today is deep neural networks. It's amazing how a very complex problem that requires very specific algorithmic expertise can be solved with a neural network. And now the good news for Ambiq is that we can run those things really efficiently because of our super power efficient processor. I can run a neural network efficiently.
You're not burning power with complexity.
That's right. That's right. So you know, the one thing we know about neural networks is that they're constantly getting bigger and heavier, and they need more processing power. Well, you got more headroom with Ambiq there. But if I was a developer, if I was, you know, one of your community members, I'd be thinking about how can I put a neural network to good use. And in order to do that, though, I need sensors that are feeding me data. I need displays like we've got in the display kit, kind of feeding that data back to the user. And there's two areas that I would be looking at for neural network use. One is audio. We have a lot of on-chip audio peripherals on Apollo 4, so ADC as well as PDM, so for a digital microphone interface.
We're seeing a real trend with audio, by the way. We're seeing a real. I mean, that you saying audio is in line with everything that we're hearing.
Absolutely,
and a lot of very interesting new startups in the audio world.
Absolutely,
so that's interesting. So you're absolutely in line.
So yeah, audio is a big one. And it's not just, I like to think of audio as a sensor, right? Sometimes we think of it as a UI device, like I'm talking to my watch or my thermostat or whatever.
Yeah.
But it's also, imagine in a watch or in a thermostat, the sound in the room tells you something about the room, or the sound of my breathing tells my watch something about how my health is, right? So think of audio as a sensor, or a microphone as a sensor. The other one that is not quite today, but is coming soon is vision everywhere. So there are low power cameras that are coming out. They're amazing.
We see that too. Yeah.
And you can imagine that that's, you know, important area for us. We have customers that want to use Apollo for that use case. And again, neural networks are your friend here, right? So whether you're talking about audio data or image data, neural networks are the tool that you really want to use to help extract meaning from it, right? And so I'm excited about all of that. I'm excited about neural networks, excited about audio, and then in the near to midterm, excited about vision and what that might mean for our customers. At the end of the day, actually, a camera is the most versatile sensor you can imagine, right? A camera can determine motion. An accelerometer can determine motion, right? But a camera can do motion. It can determine gestures. It can do segmentation of the room. It's an amazingly versatile sensor. So we're excited about where that will go.
Okay, very, very good. Scott, I think today's been an absolutely fantastic introduction into. I'm not even going to try and summarize it because we've covered.
Well, you've done a good job. I appreciate the site summaries along the way. You've done a good job.
We've covered a lot of stuff there. So I'm not going to try and be intelligent enough to try and remember it all. But certainly, let's remember the name Ambiq. Certainly, let's associate that name with low power. Let's associate that with lots and lots of peripherals, which gives flexibility for applications. And a very bright future, and a company that is health. As I said, I took it from everything that you said and the way that you said it, that there's this sort of very healthy obsession with problem solving.
Yeah.
So that's great, and it's been fantastic having a chat with you. Thank you for taking the time to share your intellect and your knowledge and your company's vision with our audience at ipXchange and your IP experience. Thank you very much.
Excellent.
So that was Guy's IP experience with Scott Hanson from Ambiq. And wow, I think this might have been one of the best ones we've ever done, if not the best one we've ever done. I can't believe the voltage power equation actually came up in this. But I think it was very necessary to illustrate how using the leakage current from a transistor as the on threshold for your processing binary really, really does slash the power consumption and makes Ambiq the lowest power processor on the planet. So I've written up the display board. Check it out in the description and apply to evaluate this technology in your next wearable. Just wow.